Good morning, students. Today you are going to have a substitute. I am out just due to being sick, and what you're going to need to do is just watch this video today, fill out the notes, and then there's a practice worksheet for you to complete that does need to be turned into the basket before you leave today. We are now in Unit 7. We are working with equations for addition and subtraction. So we'll be working on modeling equations today. Make sure that you put this notes page in your table of contents so that you can find it quickly. Should you have an open note quiz, it is page 113. Now looking at our notes today, it says at the very top, fill in the missing number to keep the scales balanced. Now, previously we talked about how you guys have seen problems like this before in elementary school, and how you're supposed to solve for the missing box in order to either complete the equation or fulfill a scenario like this where you are, finishing the scale or finishing the picture. So that's what we're going to do this morning. We're just going to practice that really quick and then get right into solving one-step equations. So when looking at the first scale, all the way to the left, it says 11 minus blank equals 6. And I'm just going to put a little equal sign here so that we get into the mode of viewing equations. So now, knowing my math, if I count back from 11 to 6, that's going to be my difference. So that's going to be my missing number. So if I count back 11, 10, 9, 8, 7, 6, if I'm using my fingers, that would be 5. And I know 11 minus 5 equals 6. Okay, same concept can be used for the second scale. We have 4 plus blank equals 10. Now I know if I count up from 4 to 10, that's going to be 6. That's the difference between those two numbers. So 4 plus 6 equals 10. And then finally, for the last one, 3 plus blank equals 15. Okay, if I count back from 15 to 3, I would end up with 12. Or if I had 12 and I counted up to 15, that would be 12 as well. 3 plus 12 equals 15. So now all of my scales are balanced and I have completed the missing boxes. This concept is what we're going to continue using today as we start writing out equations and solving them. So down here in our vocab section, solving equations allows you to find a missing value or a variable. So even though in the top we had a missing box, what we will now be using is a variable for that missing number. So instead of a little box, we're going to have a letter. Okay? So for the first bullet point, the variable must be alone or isolated on one side of the equation. So right here in this first box, I want you to write variable. The variable must be alone or isolated on one side of the equation. Okay, so that's the whole goal, is to get your variable all by itself. You want it to be a loner all by itself. Isolate the variable by using inverse operations. Remember, inverse kind of means to undo or the opposite. Okay, and then it says keep your equation balanced. So whatever you do on one side of the equation, you have to do on the other, which we'll show here in just a moment when we start solving them. And then you got to check your answer by plugging your answer back into the equation. Okay, so again, the variable must be alone or isolated on one side of the equation. That has to happen. We do that by using inverse operations. Whatever you do on one side of the equation, you have to do on the other. So you got to keep your equation balanced. And then you can check your answer by plugging in your solution. So Further down for number 1, use the key to write and solve the equation represented below. So we already got some models here, and this is our key. It shows us that this is a positive x, this is a negative x, this is a positive 1, and this is a negative 1 right here. So therefore, my equation would look something like this. This is going to be x, there's only one of them, so it's going to be all by itself, plus 4 equals, I'm going to count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, they're all positive 1s, so all my numbers are going to be positive, and I also have a positive x, so all of my x's are going to be positive. Now, when looking for my solution, if I follow the steps up here, okay, I know this is an easy problem, and you can figure out that x equals 6, but if you didn't know that, this would be how you would solve this problem. Okay, we've got x plus 4, and that equals 10. In order to isolate my variable, I would take away my 4 from this side to get 0. And whatever I do on one side of my equation, I also have to do on the other side. So I would also take away 4 here. 10 minus 4 equals 6. So therefore my x equals 6. I know that this is true because if I plug my value in for x, 6 plus 4 equals 10. Okay. So the inverse operation of addition is subtraction. If you have 4 and you want to get rid of a positive 4, you would take 4 away. So you're going to subtract that 4. All right, let's go ahead and move on to question number 2. Write and solve the equation represented below. Again, I have 1x, so that's going to be x. And then I have 2 positive numbers with it, so that's plus 2. And then my equal sign, and I have 6 positive squares over here, so that equals 6. Again, you can figure this out on your own. I'm sure you know that x equals 4. However, we're going to practice solving these equations the proper way, so we know x plus 2 equals 6. If I want to solve for x, I would do the inverse operation of addition, so I would take that 2 away from my x so that it's all by itself. Whatever I do on one side of the equation, I also have to do on the other. So I'm going to take 2 away. 6 minus 2 is 4. Therefore, x equals 4. And I know this is correct because if I plug 4 into my answer, 4 plus 2 equals 6. Number 3. All right, they're getting a little tricky this time. So we're going to write out our equation. I have 1, 2, 3, 4 positive squares equals x plus 1, or 1 plus x. It doesn't matter your order because remember addition can be written either way. If we were to write it exactly how we see it, it could be 4 equals 1 plus x. Again, it doesn't really matter the way that you write it. Now, again, I'm going to solve this equation. There really is no difference between what you're going to do if your x is on the left side or on the right side. I like to rewrite it so that my x is on the left because it just helps keep things organized. So if I was to just swap these terms around, x plus 1 equals 4, it's all the same, but this way I'm keeping my x on the left side, and because that's mainly how you're going to see it. It just keeps things organized. So if I take 1 away on this side to make my x all by itself, I also have to take 1 away over here. 4 minus 1 equals 3, so therefore I know that x equals 3, and I know this to be true because 3 plus 1 equals 4. On the back side of your notes page, we're just going to keep on going because we're now working with negative numbers. So we're going to write and solve the equation represented below. I have 1x, but now I have a negative 1 and a negative 1, which would be minus 2, equals positive 1, 2, 3, 4. Okay, so now x minus 2 equals 4. Instead of adding to my 2 like I just did previously, I have to do the inverse operation of minus 2. So if I want to get to 0, the inverse operation of subtraction would be addition. Remember, I want to isolate my variable, so I want to add 2, making that equal 0. Now x is all by itself. Always drop your x down. Now whatever I do on one side of the equation, I have to keep it balanced, so I have to also add 2 over here, which would give me 6. So x equals 6. And I know that this is true because 6 minus 2 equals 4. For 5, write and solve the equation represented below. Okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 positive squares equals x minus 1. Okay, so again, I'm going to go ahead and rewrite this so that my variable is on the left side. So I've got x minus 1 equals 9. I'm going to do the inverse operation of subtraction to get my variable all by itself. So I'm going to add 1 here. Now my x is all alone. I'm going to draw a line here so that I know I got to keep things balanced. I'm going to add 1 to my 9, giving me 10. So x equals 10. And I know that this is true because x minus 1 equals 9. Okay, so further down here for question number 6, I'm just going to do one of these with you, and then I want you to try and do the rest by yourselves because you guys have a good grasp on what to do, I think. Just look back at your notes if you get confused. The concepts are still the same. So if I have x minus 6 equals 12, okay, remember I got to do my inverse operation. So I would add 6 to this side. I'm going to drop my variable down. This equals 0. I'm going to balance this out by adding 6 on this side. Okay. And now 12 plus 6 equals 18. X equals 18. I know that this is true because x minus 6 equals 12. Or 18 minus 6 equals 12. Now, it says check and graph. Here you're just plugging in your value. So instead of x minus 6 equals 12, you'd put 18 minus 6 equals 12. Okay? And we know that that's true because we know math. All I want you to do for your graph is just to draw a little dot here, put 18. Okay, whenever you write a solution for an equation, because there's only one answer, you can just put a dot right there on the number line and just show me that you know how to use a number line. There's nothing really to it. Just write the solution in the middle of the number line for this worksheet. And then as we get more into equations and inequalities, using the graph and the number line will make more sense. Okay, so keep going with this worksheet. Try and solve the rest of these by yourself using all of the information that we just talked about on this notes page. You guys are going to do just fine. You got this, okay? And have a good rest of your day.